This is Sarah Pessognelli, and I am going to be doing an explanation and walkthrough of my movie recommender. For the agenda, we'll be going over our problem statement, a description of the data, an explanation of my proposed solution, a quick walkthrough of the code, and then some conclusions and future work. So the problem statement, the issue that I wanted to try and tackle is, if you've ever been listening to Netflix or Spotify, and all of a sudden it gives you a recommendation that is just very far out of left field. It's something that you don't have any interest in, but the caveat to that is that in general, it's popular. The goal here is to try and fix that by making a hybrid movie recommendation system that bases its recommendations on, one, movies that others with similar interests have watched, the ALS approach, but also on, two, how similar those movies are to movies you have already seen and liked, a content-based approach. So a data description. So we're using the movie database available on Kaggle. It has two CSV files, both of which we will need for this. One is movie metadata, and that contains about 45,000 movies, their name, the year they were filmed, their cast, the genre, a lot of metadata about the movie, most importantly, a synopsis of each movie, a written overview. The other data set is ratings _small. That contains about 45,000 movie ratings from various users, rated on a scale of 1 to bad to 5 excellent. So the proposed solution is, first we are going to use the ratings to find similarly liked movies using all the information from other users. The drawback of this doesn't count well for genres or similar synopses. And even though there are some movies that are universally liked, like The Godfather, if you only watch animated movies, probably not a movie that needs to be recommended to you. So the idea is that we use this ALS system, we get the top 50, and then we feed it forward into our content-based system. So once in the content-based system, we take those top 50 ALS movies, we grab a synopsis of each, tokenize, clean, create the TF-IDF matrix, and then grab the movies liked by some user. We're going to use user 16 that are above our liked threshold. Here we're going to say anything up over a 4 out of 5 is considered liked. We'll filter that matrix based on liked movies versus movies that you have watched but maybe didn't care for, and then we will compute the cosine similarities of those movie synopses with the synopses of the movies that user 16 has actually liked. The output will be the top 50 movies recommended by ALS re-ranked by how similar they are to a user's liked movies. So we'll now do a quick walkthrough of what this looks like. Let me get us back to the top here. So first we're going to import our Spark and data libraries. I'm using CSV files hosted on Google on Google Drive. We'll initiate our Spark instance and we will load our data sets. We have two. So DF is going to be our movie metadata. And then in the ratings data set, they are only identified by an ID number. There's no name, so we're going to create this names dictionary so we can move easily back and forth between the two data frames. And here we will start making our simple ALS system. So all we have to do is use the ALS module from PySpark, give it our data frame that we are training on, and we can display the subset, the top 50 recommendations for all the users, and it outputs that as a list based on their user ID. So then what we'll do, this is just some exploring that data frame, but what we really need to do is get the information for the user that we're interested in. So that's user 16, just as an example. So we're going to grab their user information, the recommendations that ALS has given them. We're going to explode it out into its own data frame so that we have the top 50 movies based on their ALS rating, ranked by their ALS rating. And then we have this data frame to feed into our content-based recommender. So now we are going to use our DF data frame that, as a reminder, is the metadata. We have this column here, sorry about that. We have this column here, overview, which has a brief synopsis about each movie. So using the overview column, we will tokenize, remove stop words, which are words like a, is, the, and stuff like that, filter all that out, get our TF IDF calculators using the, calculation using hashing TF, part of the PySpark library, and then get the TF IDF calculations based on those filtered words from the overviews. And then we will store all this information in a matrix data frame. It's not really a matrix, it's just a list, but that's good. So now we will get the movies that user X has liked, so user 16 in our case. We grab all the movies that they have rated. We set our threshold to 4 out of 5. That's what they are considering. That's what we are considering a liked movie. We sort by, filter by that threshold. And then we can get the movie IDs for each of these liked movies, and then do the same thing. Create a TF-IDF matrix, and then using that and UDF, a UDF lambda with the lambda function, we can then create a cosine similarity list of recommendations. We can sort those recommendations by similarity, and its output here. So as a recap, what it did was we calculate the TF-IDF matrix for all movies. We get the movies that user 16 liked, calculate the TF-IDF matrix of all those movies, calculate the cosine similarity matrix between those two matrices, so all the movies and movies that user 16 liked, and then we sort by that final similarity, and we get our recommendations. So the top 3 movies for user 16 to check out should be Boogie Nights, Spanglish, and Sparrow. So conclusions and work. I think it's important to note that ALS kind of already does take into account the rating, like the 1, 2, 3, or 5, etc., given by each user. And the ultimate purpose for this would be somebody who doesn't frequently watch or like specific genres. Users that have a wide range of preference probably won't really see a benefit from this hybrid approach, but if you really don't like metal music, this should help Spotify never recommend metal music to you. And for future work, I thought that it would be interesting to look at user demographics, but we didn't have any of that. So things like their occupation, their location, their age, sex, things like that, and to see how it would affect movies that they end up being recommended. Thank you for listening. Hope this was informative.